Hi, my name is Rico, and welcome to Petals for Your Troubles, wherein we will be helping you solve problems in 2 dimensions. Let's go!
A robotic vehicle/rover is exploring the surface of Mars. The stationary Mars lander's origin coordinates and surrounding Martian surface lies in the XY plane. The rover, which we present as a point, has X and Y coordinates that vary with time.
Wait.
Hello? Yeah, thanks for calling me. Physics is really hard, and that's actually why I wanted you to call me, because I am having trouble with physics, and it's really hard for me. Yeah, I know. Yeah, I know. I'm not the brightest. I'm the most attractive, but I'm not the brightest. I know. So, well, yeah.
How about right now?
Oh, how'd you get here so fast? What happened to the lights?
Need help in physics? Well, here, let me show you.
A is basically asking you to find the rover's coordinates and distance from the lander at 2.0 seconds.
Now, to look for the coordinates of our rover, we have a function which is already given to us for x and y. So all we need to do for that is to substitute our values with our time at 2 seconds. And to look for distance, as you see in this arrow here, we just basically use the magnitude formula, which will then add it to square root of a squared plus b squared.
Now, B is asking you to find for the rover's displacement and average velocity vectors for the intervals from 0 seconds to 2 seconds.
Now, to look for displacement, we already know that our values of 2 from letter A is already given. Whatever that may be, you subtract it now to your values of 0, because as this is our origin, subtracting this whole thing will give you an answer, and with this will be our displacement. Now, to look for average velocity, we now have an equation that is universal, which is velocity is equals to distance over time. Now, our time will be 2 seconds, as that is displacement, and d, which will obviously
be our displacement/distance. Now, these are the x and y equations that we will be using to input in our time at 2.0 seconds. Let's start first with our x.
Let's work with our variables independently. As x is this equation, we now know that our time is at 2.0 seconds. As we input that in, we then cancel out like terms. As this second squared is cancelled out, you're now left with 0.25 meters times 2.0, which is basically 1.0 meter. And then we just copy this down here, which is 2.0 meter minus 1.0 meter, which is obviously 1.0 meters. This is our x value. Yes!
Now let's work on our y value. While we substitute in 2 with our y equation, we will then be looking for our answer, which is...
Now, working on our y variable, we now have this equation, and all we have to do is substitute 2.0 seconds to our t and our times cubed. As we see here, we're simplifying it by crashing out our like terms with a seconds cubed, and per seconds cubed. All we have left to do is multiply 2 and 1, which gives you 2 meters, and then our 0.0025 meters multiplied to 2, which will give you 0.02 meters, which will then yield you an answer of 2.02 meters. Yay! And so, with this, we now have our x and y, which is y at 2.02 meters and x at 1.0 meters. Now that we have our y and x, or x and y variables, we now look for distance, which is basically the magnitude formula. As I've already substituted those in for a and b, the answer of this will yield you to 3.6 meters. And this is how far the rover has traveled after 2 seconds from the origin. Okay.
As we now have our answers for A, we take in these answers to look for our answers for B, which I will be writing down these equations.
Displacement and average velocity, we now take in the values of 2.0 seconds, which we've already done here, and we subtract it to the values of 0.0 seconds, which is 2.0 meters of x and 0.0 meters of y. You can review this when you're solving it, and you can check that it's the same, which will then give us an answer of negative 1.0 meters of x and positive 2.02 meters of y. And now that we have this answer, we basically just translate this to our average velocity, which is displacement or distance divided by time, and our time here is 2.0 seconds. And so we put that individually. If negative 1.0 meters divided by 2 is equals to negative 0.5, and our y is 2.02 divided by 2 is 1.01.
And these are our two answers! Yes!
And that's how you solve problems in 2 dimensions. My name is Rico, and thank you for watching Petals for Your Troubles.